All right, in example 2 here, it tells us to prove the identity. And it gives us a note here. It says work the left side unless the right side is obviously more complicated. They usually put the harder side, the more complicated side, on the left. And so that's typically what will work. But sometimes we'll say, you know what, I think I better work the right. So in that case, we will. But here, if we notice, the right side is just tangent squared of beta. So let's go ahead and let's work the left. So I'm going to draw my line here. And let's see what we can figure out. All right, so on the left side here, I have 1 over cosine squared of beta minus 1. First thing I notice is 1 over cosine squared of beta. We're not real great with fractions. We don't really like them. So what is 1 over cosine squared? Look through your identities, guys. We're using those same identities that we talked about in 5.1, okay? So 1 over something makes me think a reciprocal. So if I look at my reciprocal identities, I see that 1 over cosine is equal to secant. So 1 over cosine squared will equal secant squared. And so I have secant squared of beta minus 1. But wait, there was an identity, and hopefully you've all already done this. I've asked y'all to. That said that tangent squared of theta, or x, I don't remember which one we had used, plus 1 equals secant squared of theta. And so I'd asked you to go ahead and work all these so it'll be easy for you to identify getting each part by itself. And if you did, you should have tangent squared of theta equals secant squared of theta minus 1. Because remember, I told you when I see a trig function squared and a 1 together there, I'm thinking Pythagorean identity. So I'll look in that area first to see, do I have a formula like that? And I do. Secant squared of beta minus 1 then is going to be equal to tangent squared of beta. Well, guess what, guys? That's what we wanted. So I want you to write it out here, okay? This is how I require it. So you simplify that 1, you bring down the other side, box it, because I'm saying I've got it. I'm done. And then if you want, you can do QED. It is finished. We have demonstrated it.